All right. So, let me tell you a little bit about the Play framework in production. My name is Chris. I'm one of the co-founders of Mir. And so what we do is we help people create beautiful travel guides. And when we started, it was back in February, we had a discussion about what web framework would we want to choose and which language actually we want to choose. It's a very difficult thing. There are lots of frameworks, languages out there, so how do you actually decide? So for me, because I was the only developer then in the team, I had some experience with PHP, Java, C#, and a little bit of Scala. And I felt like, what technology actually to choose? Not even a web framework, but even before that, what language would you choose to start a web application right now? And for me, I think for languages that are very popular, like Java and PHP, of course, it's very easy to find developers, and that's a big advantage. The other thing is that you have big code bases, you have frameworks that are very stable, very old. And for Scala, it's a bit different. It's hard to find developers, but then I really liked a lot of aspects of Scala, and I think the biggest aspect is the expressiveness. I think that you're more productive if you can write more concise code, and it's easier to document and for other people to understand what you're doing if you don't have to write lots of for loops and this kind of thing that you know from Java or PHP. But still, it's hard to find developers, and I think it's actually may even be an advantage, because you find lots of PHP developers, and if you find a Scala developer, it's actually a good filter. You probably get some people who are interested in new languages and like to self-teach them and are very autodidact. And of course, it's a lot of fun to write Scala, and so we went with it. And in February, when we started, we just put out a launch page. We tested how Play framework would enable us to get something all done in just the weekend, just 3 days. And we're sitting there. Here is Stefan, it's our second developer now. And we just fired up IntelliJ, our favorite tool to write Scala, and we just put our Git repository on Dropbox. I don't recommend you should ever do that, but that's what it was a quick fix for a repository that shouldn't be public. And we started using Play. And if you don't know much about Play, it comes with a very nice developer console. You just write new application and it generates a scaffolding application for you. You just type in the name of the application and you can run it and extend it from there and build your application. It also allows you to make some changes and just refresh your browser, and you see the new page online. It restarts itself, much like a script language would do, like PHP or Ruby on Rails. And there are also Java tools that can do that, but it comes with the Play console and it's very nice to get started. And well, we use the tool also to package the application and put it on Amazon on the cloud and run it there. So it was really, really quick to get started. And so what did we learn about starting with Play? It is a very forgiving framework to start with. What I mean with that is you don't actually have to know a lot about the framework. It's a very powerful framework in the back, but you don't have to understand it completely just to be productive. You can start with very simple things, put your pages out there and learn it while you're building your application. This is actually what we were able to do. As you get more and more requirements, of course, you need more and more libraries. Maybe you need to interface with other things. It gets more and more complex. We found that it really adapts to the needs, and you can change the parts of it so that you can use all the modules that you want. Now I'm going to confront you, even though I didn't tell you anything about how Play really works, with our first production code. You can see that Play uses a lot of concepts from popular frameworks like Ruby on Rails that are MVC. So you have models, you have views, and you have controllers, and you have a routing system. So it doesn't try to abstract away that you want to build a web application, that you're dealing with HTTP, which is a stateless protocol. You have routes, and you define, when a user types in a certain URL, what controller should handle that route, which controller should handle that route. And so we have here in this first piece, we have a route that it's activated when the user goes to the main page. It's just a slash, and wants to get, so the browser uses the get request to get this page, and you define a controller. That controller has an action that you define, and this action just in this case returns the rendered view of our main page. It's a very simple concept, and many popular frameworks use just this type of architecture. You have routes, you have functions that handle these requests. We call them here actions in the controller. And then you have views that render some HTML or JSON responses or what have you. And this is a very important concept. We will get back to that. The advantage is that you never have to hard code these routes again. So you just define them once, and whenever you want to render a link for the user to get back to the main page, you just call a reverse controller, so-called reverse controller. Tell him that you want to show the main page, tell him show main, and it will automatically return the URL without any without any arguments. So the question is, these are very simple examples. How does it look like when you really get messy, when it really gets messy, and you need lots of more things than just returning static HTML? You need probably database access, you need internationalization, you need lots of stuff. So, well, of course it doesn't stay that simple, but the argument is that it's still readable, and you can, using Scala, you can factor out a lot of the things that you need very often, and it's a very nice framework to extend. And although this looks a little bit more complex, I want to just explain you a little bit what this actually does now. We're still showing our main page, and this is actually our production code. But there is a little more going on now. We extended the normal action with something that handles authentication, and we can show the user a nice profile picture if he is logged in, and we show him a login page if he is not logged in. We show him just a login link. Then we have something that is related to search engine optimization. We want to have nice URLs. If the user visits our page and he or she wants requests the German page, but she got actually the English link, what we do is we check if the language that the user actually wants to see corresponds to the URL, and if it doesn't, we redirect him to the correct one. And this is what that does. So this actually redirects you to the correct URL, which is translated. So the URL is, for example, in German, whereas the other one is in English. Then we have
So isn't that hurting your search ranking if you have different links for the same content?
It's not the same content, it's a translated content. It's very important actually that you have pages, that you have that you have different URLs for different content.
Okay.
It's very important. And what we did before is we used Play's automatic translation internationalization module, which just translates the page to the correct language, which is of course nice. But what happens is the user with English accept language header gets the English page, and the German user gets the German page with the same URL.
And why is it important that the URL is different?
Because the search engine doesn't send you an accept header. The search engine needs them to be two different pages, two different URLs. You want to have two pages if you have a German and English
German
content.
People find the German page.
Yes.
In a way.
Yeah.
Okay.
So this lets also Google index our English pages separately from the German pages.
Okay. I see.
When you type in and you search, you get to the correct page.
Okay.
Then this handles the translation itself with the correct language now. And then we have here some caching, so we don't have to access the database all the time, because this is our front page. You can of course do more complex caching stuff, but this is a very simple inbuilt caching system. And here we have actually a database access where we fetch the offers and the guides for our main page that you actually saw here. So here for people on the left side and are some featured offers, and on the right side we have two featured guides, and these are the ones that we actually fetch here. So there is a lot of stuff going on, but I think it's still a very nice framework, and you can actually still understand lots of stuff what's going on here. And the things that we need more often, we can factor them out into separate functions, like the rich action or the translate function that handles the redirection, and the other things like caching.
But for the cache, is it not necessary to include the language in the cache key?
I think you spotted a bug, maybe. I think you should fix that, yeah, definitely. Thank you. Okay, so back to what that actually does. As I told you before, you have these actions, and one of the basic things in HTTP, of course, you have HTTP requests. The browser sends HTTP requests, and these contain URL, parameters, and cookies from the user. The other thing that you want to have is, of course, the response. The user needs to get some data back, and this is the most basic thing in the Play framework is the action, which just takes a request and returns a response. And the question now, with this basic principle, how is it extendable? And it's extendable in a very nice way, because sometimes here in the request, which is from the Play framework, a case class which contains these parameters, cookies, and the other things, but maybe we want to have a request class that contains additional information that we want to have in our views. For example, what kind of user is accessing a page? Is he logged in, and what is his name, and what's his ID, and other things? What rights does he have? Does he have the right to access this page? And this is where we can compose actions. And just to give you an example, please tell me if there is something that, well, I'm going to have to assume that you read some Scala code before, but if there are some questions about the syntax, just ask. One way to extend the request in Play is with the wrapped request. And now we just make a new request class and add our maybe user session to that. And we want to have something that contains our user session if the user is logged in. So in our view, we can then decide, okay, do we have to show him the logged in menu, or do we have to show him a sign up link or something like that? And for this we can extend the request. Then we implement two different types of requests. We implement the one where he isn't logged in and the one where he is already logged in. Just overriding the methods. And then finally we can implement a new type of action that now gives us the new type of request that we just defined. So we can now write our application just like we did before. Just have to replace action with reach action, and what we get is not the normal play request, but we get our new request. And what we have there is the information from the user session. So with this last object here, the reach action, we check if the request contains some cookies, session cookies, some database stuff that's hidden there in the auth check function. Because it's not interesting for extensibility of play, but this stuff happens in here, and we can now just work with the authenticated request if the user is logged in, or with a default request defined here if it is not. Are there any questions?
Where is the composition? Sorry, I missed it.
Composition happens here. Because here we use the
the action. Okay.
So there is an action inside this image. Okay, so to get more of an overview about what happens if you want to develop a big web application that uses lots of different services, you of course need a framework that allows you to do that. And we use a lot of different services. We use, for example, Amazon S3 to store our pictures. We use at the moment MailChimp to handle our newsletter lists. And we use Slick for database access. It's a very nice wrapper. And just on the front side, we have a lot of style sheets. We need to manage them. So we use something that compiles to CSS. So we have style sheets written in less. And for our rich application editor, where people create travel boxes, we use AngularJS, which allows us to create these applications that just react to the user instantly and just need to transfer data to the server and back. But of course, there are things that when you start out with a new framework that can be difficult, and so I want to talk a little bit about the mistakes that we made when we tried to integrate all these things. So, like I told you, we use Less, which is a language that's similar to CSS, but you can write with less verbosity. You can write in a more concise way what you want to express, much like Scala compared to Java. But the Play framework comes with complete integration of Less. So you can just write Less code instead of CSS, and it will automatically compile it for you. The problem is just that it runs inside a Java virtual machine. So Less is written in JavaScript. The compiler is written in JavaScript. And so what they do, they use Rhino, that's a JavaScript interpreter for Java, to run this compiler, and it's quite slow, and it's not a lot of fun if you just change a few colors in your style sheet and you have to wait 20 seconds for the page to refresh. So we had to drop that. And so what we did, we completely dropped the Play support for style sheet compilation and switched to the original compiler, which is written in Node.js. And during development, you maybe don't have Node.js on your computer for development. We use the in-browser version. So this is one thing that we couldn't use out of the box, or at least after a while it was too slow.
And did you really have very huge less files? Or?
Yes, because we started out using Bootstrap, Twitter Bootstrap style sheets. They are already written in less, and they are like, I don't know how many lines of code, but 150 files at least. And if you make a little change there, and you have to wait 20-30 seconds for the page to refresh, it's not very nice.
But why are you? So you are changing the Bootstrap CSS. Sorry, the Bootstrap less files.
Yes.
Okay.
So we started with a clean Bootstrap distribution, and then we gradually adapted that. In the beginning, we just thought maybe just override the styles, but it's not really the way it's supposed to work. You have to change the styles.
Because that's the way I usually do it. I override.
Yeah.
So I have the vanilla Twitter Bootstrap, and then I have.
Yeah. Well, Bootstrap is probably another topic for itself, but it's really made for changing some of the variables that come with Bootstrap. And for example, you have like font size that we changed and this kind of stuff. So you can really adapt it. It's fine. Another thing that maybe was a mistake, in the beginning we didn't use any reverse proxy before Play 2. So Play 2 comes with a built-in web server. You just run it, and you can use it in production if you want, but it's not really recommended. And we did it anyway. The problem is it's not very good at handling SSL. So if you want secure pages with HTTPS, it's better if you just have your Play server behind some Nginx or Apache server, web server, and just proxy the requests there. And in your Play application, if you need both HTTPS and non-secure pages, you can pass some browser headers from the proxy server to your application, so your application actually knows if the user is coming over HTTPS or normal HTTP. So, yeah, my recommendation is definitely start using it with a reverse proxy. Another thing is growing JavaScript code base, which can be very hard to handle if you hard code the routes, for example. I told you in the beginning a little bit about the routing system, and the idea is really that when you have a big application, you have so many different URLs, and maybe you want to change some of them, or you want to make some redirects. The problem is maybe in your JavaScript code you need some post requests, change some data on the server, and then you have to refactor them too. So how do you find all these wrong routes? And
Let the user test.
yeah.
Let the user test.
Can probably do some integration testing or something like that, automated tests. But a very nice solution comes actually with Play. Play supports JavaScript routes. You just say which routes you want to export to your JavaScript code, and it generates the JavaScript for you. And in JavaScript you just don't write like here the URL like it looks, but you write actually what action you want to call on the server. And the same we did with translations. We have our page now in English and German, and we have lots of snippets of text that need to be translated. And we have now a function that generates, or Play generates the translations from our static translation file into JavaScript. And all that stuff is, for production, is minified and compiled using the Google Closure compiler.
Is it key-based, the translation?
Yes, it's just key-based, yeah.
But how does it work?
In JavaScript you call a messages function, pass it a string, and you get the translated version. And we include a different JavaScript file for German and for English users. So we compile everything in one package, and then there is an English package and a German package.
And why you don't use the built-in translation on the Play side, on the server side?
On the server side we use, for the templates there is a built-in messages function that translates text. But in JavaScript, you need something else.
This is only JavaScript translation.
That's the JavaScript version, yes.
So you just have this messages object,
Yep.
and then if I have an English browser, then you
Yep.
deliver another
Exactly.
JavaScript
Yeah.
package.
So the JavaScript actually doesn't know in which language it's running. It just has this array of language strings. All right. The last mistake for today is Play is a framework that builds on actions which can be run in an asynchronous way. So what you can do is, we heard a little bit already about futures today. I'm not going into much detail right now, but what you can do is not return a response, but return a future of a response. And you can write code that fetches data from some other web service or even a database and does not block while doing so. You can wait for the result, and then if it's there, send it back to the user, and you don't have to consume a whole thread for that. So while your Play application is waiting for the database to answer, the same thread can serve another user's request. This is possible with Play out of the box. The only problem is that there are very few database connectors that support that. And I think MongoDB supports asynchronous requests, but any SQL database doesn't support that. So right now there are no libraries that allow you to do that using a normal SQL database like we do.
As far as I know, GDBC doesn't support it.
Exactly. So
I
GDBC
think
doesn't.
there's some asynchronous Postgres SQL connector, but then you don't have GDBC, so
Yeah.
you probably can't use Slick.
Yeah. Slick wants to go away from the JDBC dependency, so they will support asynchronous stuff, I think, for MongoDB, but for normal SQL database, you still have to use synchronous, you still have to wait for your result and have to have an extra thread. And this is where this mistake comes in. You need to configure Play to have more threads than a default setting. So the default Play setting is that you have 2 threads per core, which means you can serve thousands of requests, but only if you use asynchronous code.
All the way. So
All the way, exactly. So you need to respond with futures if you use databases, which we don't do because we use Slick, and Slick is a classic, at the moment classically asynchronous, and so you have to pump up the thread pool for that to have more concurrency. Okay, so maybe let me tell you shortly just a little bit about Slick, if you're interested. Yeah. Slick was another technology choice to be made. It doesn't come with Play right now. I think they are going to build it in the next version, but right now you have to use it as an external module, and it's actually a table on the database. So what you do is you write a for comprehension, tell it you want to get some guides from the guides table, and you have some filter there, get me only the ones that are visible, and returns them. And one very powerful thing about that is this is now just a query. It's not executed yet. So this function displayed guides returns you a query that can be extended. So what you can do is you can combine queries to a new kind of query, and you will never have to, if you're composing SQL, you'll never have code duplication again if you don't want to. So in the second one, this is where it's actually executed. We take only those guides, so this behaves like a table, but it's actually a filtered table. So if we have some logic that's very complex filtering logic, we can just put that somewhere else and use it again here. And this whole thing will create an SQL statement out of these different types of functions to get you all your stuff that you want. So in this case, we get some guides, they are filtered by the visible flag, and then we join them with another table, the guide category. In our case, we have guides and they have one specific category, we join it here. So this is like SQL join, it's just written in Scala. And if we return the ID of the category, then we group it so we don't get duplicates, and return just the ID. So what it does, it returns a list of integers, a sequence of integers.
How is it fine-grained the control about the joins and this? Because okay, this is nice, but it looks in SQL it looks like a simple select.
You look at what?
As a simple select.
Simple select.
Yeah, two tables joined with some criteria. That's
Definitely,
all.
yes.
And
Yeah.
in the end, this is some projection.
Yeah.
That's all.
Yeah.
But when you have some complicated select with unions or
Yeah.
left out the joins and these things,
You
everything
you can combine everything. So you now, if you want to reuse this statement and maybe do some other things with the grouped IDs on the database server, you can just leave out the list statement. The list statement is the one that actually executes the query. Sorry, I didn't explain that. But the list is the only reason why this function needs a database session. Because here it's important. Now I want to query this database right now, and I want to get the results. The rest, if you just leave out the list, the rest is just construction. You can again reuse it and again write even more complex
But my
subqueries
question
or
was,
whatever.
it's also possible to make somehow left out the joins.
Yes, you can make all the
unions.
unions. I don't think all the database.
How rich is this syntax? That's the question. What
okay.
can you express in this syntax?
I think they had to leave out some database specific stuff, like, I don't know, a few string functions that are only supported on specific types of databases. So they try to be database agnostic. They want to support like 10 different databases, so you cannot use all the special functions. You can, if you want, write SQL and extend Slick even to use your database specific functions, but the most basic stuff is supported. You can do all the ANSI SQL things. You can convert strings to integers and all these kind of basic stuff.
And also, like in Scala, you have left join, others join except as function. So
Exactly, yes.
If you really want to, you
Yeah.
can go in and sort of say, this is how it's going to be joined.
Yeah.
This is how-
But maybe Slick would be a topic for, I think,
looks like.
a whole new session. But it's amazingly stable, so we didn't have any issues with that, even though like Play itself, it's pretty bleeding edge, and it's still amazingly stable.
For you,
For me.
because you started late.
Yeah.
But it's gotten really well.
Yeah. All right, just to get to think about a little bit about the last 3 months using Play. One of the, I think, most helpful things about Play is the code base. It helps you actually to become better at writing Scala. I think it's really well written framework. It's very well documented on the code level, and if there is something that you don't quite understand from maybe the lacking documentation sometimes, it's very easy just to look inside and to get a sense of how they do things internally. And it's from the stuff that I had to dig into, it's really nice to learn about the framework. As I said before, you have a lot of stuff built in, like the less compiler, which is really nice if you just want to try things out and get started really quickly. But as the application grows, you can switch stuff off and throw it out and replace it with something that maybe fits you better. It helps you to keep your code dry, so you don't have to repeat all the things that you need to do for all your pages, like authentication, translation, and all these kinds of things. And recently there were some performance benchmarks from the now very popular Tech and Bauer blog. If you want to read about how fast the frameworks are now in comparison, I recommend you to Google the Tech Empower benchmarks. It's very interesting. Play is not the fastest web framework, I can tell you that, but it's pretty good. So if that is important for you, you can look that up. So just summarizing, why is choosing Play a good idea for us? I think it's because we know that code bases grow eventually, and as they grow, at least from my opinion, it's easier if you have some compiler or some system that understands and can analyze your code, and you can easily refactor stuff, rename things, and this kind of thing. It just saves you to write a few tests more in the end, because you can do some changes that don't need to be tested, like renames. And the other thing is, it's now, or it was, I think, a few months ago adopted as de facto standard web framework by TypeSafe. And much like Ruby on Rails, it's like this framework that doesn't try to abstract anything away, but really goes on the HTTP level. Finally, what I think is interesting for us as a startup is that even though you can find more developers for PHP and Java, for example, I think it's really this good filter. If you want some people who want to try new stuff of doing things, I think Scala is a good way to find the right developers. All right, thank you.
About the Scala templates, HTML templates?
Yeah, I had to leave that out of the presentation. Scala templates is basically a way to generate your HTML or even other documents by using the Scala language. It's not something different than Scala. It just has like an escape character, and then you write Scala, and it returns whatever you want to do in a template. But yeah, sorry, I had to leave that out.
But because you're using AngularJS, you're not using Scala HTML template.
We do use it, but because we're using AngularJS, we don't need as much dynamic code generation on the server. So we can load static HTML files too.
Okay, and does Play framework also support packaging and minifying AngularJS code?
Yeah. Well, it contains the Google Closure compiler for JavaScript, but they don't use it to minify JavaScript. They use it for require.js, for handling multiple JavaScript modules. So what we use is in our staging system, the JavaScript gets compiled. It's not done by Play for us right now. Because during development, sorry.
So it does not minify the JavaScript?
I think it supports minifying it, yeah, probably.
There will be a lot more also in regards to Angular support, etc. in the next release, which I read recently. And you can really configure the closure compiler, which is good because in most cases you need to configure it, and that wasn't possible before.
To do what?
To configure it so you can just customize the way your JavaScript gets compiled. Because out of the box it will just fail on most stuff, like it won't be able to compile libraries or stuff like that. Which you really don't need to compile the library itself, but standard equipment.
And what about deployment? How do you deploy? Yeah.
We now actually use TeamCity. We have two different systems, a production system and a test system, which is completely independent from each other. And when we push our code, we just run a TeamCity build, and
you push it to a Git repo.
We push it to a Git repo. TeamCity is like an automatic deployment system that detects a new code change, and in our case automatically runs the play stage command, which packages the whole application into a jar file that you can just run on any JVM. So on the server you don't actually need the play framework, you just run the jar file. It contains all the dependencies that are prepackaged. And so on our servers we just have the JVM installed and we run system and Nginx in front of it.
So TeamCity creates this jar and
Exactly.
copies it via SSH to the
Exactly.
server.
So TeamCity
and
compiles it,
kills the process, kills the previous
restarts the play process, exactly.
one.
TeamCity does that for you?
Yeah.
TeamCity is a Jenkins.
It's like Jenkins, from JetBrains.
So
Yeah.
you can keep the connection open, start a new process and say goodbye and
Yeah.
keep it on.
Well, it's not built in. We did our own shell scripts
Yeah.
that do the compile and deploy step, but it's very nice to manage which kind of server you want to deploy to, for example.
And why do you use stage and not dist? And why did you go for it?
I'm not sure what the difference is now right now.
So
I think
dist will create a zip file,
yeah.
which you then extract. It has a start bash file inside,
Yeah.
and you run that.
I think it's the same thing except without the zip file.
Yeah.
Yeah.
It's just, yeah.
And it has the advantage that if you're using rsync to deploy to our server, you can skip transferring those files that stay the same.
Okay.
Yeah.
Okay, so you just stage it and rsync directory.
Exactly.
Okay.
How do you unit test or integration test your playout? Is there
Good point. We're using TeamCity also for testing purposes. So when TeamCity detects a code change, we run automatically a Casper.js headless browser. Or actually it's a Phantom.js, right? Phantom browser, using the Casper.js JavaScript library, which you can use to integration test the application. We don't really have unit tests right now. We just start this complete integration test. We're
End-to-end tests, or-
Sorry?
When you say complete integration test, you mean a browser?
Yes, exactly. So
driving
this
the app.
thing is like a user that browses your website, and you can even make screenshots automatically, this kind of thing. In our case, it crawls our complete websites and looks for not found errors, HTTP errors. It looks for JavaScript errors. It looks for HTML errors, for example.
That's Casper.js.
Casper.js, yes.
Is it an open source tool?
Yeah, so open source. So Casper.js is built on top of Phantom, which is the headless browser, and it's an interface just to write JavaScript tests. And you tell it just to visit the URL, and it will open it in this browser, and you can listen for some errors, HTTP errors, whatever you want.
But do you then also code yourself, like workflows, like user registering themselves, etc.?
We want to do that now. Now we have this simple thing that just crawls the complete website, looks for JavaScript mistakes, which is already very helpful, and files that it cannot find. For example, if we forgot to put some image files on a production server, whatever, it detects these kind of mistakes. We can also, in the future, test complete integration workflows where the user logs in, does some stuff, and really get the complete acceptance test done.
And Casper.js has support for this?
Yes.
Okay.
Although you will have to clean up the database afterwards. Yes.
What were the other frameworks that you had a look at?
Well,
Or was it clear that you will use?
it was not really clear. I looked at PHP frameworks like Cake PHP and Symfony. I think they're very well written frameworks, but especially Symfony. but I really want to get away from script languages and dynamic languages. So for me personally, I think that statically typed is the way to go, but it's really just a matter of opinion, I guess.
Religion. Did you have
Religion, yeah.
Religion. Well, they are synonyms.
Did you also have a look at Lift there?
Sorry?
Lift what?
Did you have
Lift, yes. Actually, I took a look at Lift before play, but I really didn't like the way they tried to abstract everything. I think Lift is a very good framework if you want to do some real-time stuff. If you want to code like a chat application,
like the
long calling and this kind of thing. You can do that with Play too, but Lift really, I think, gives you a head start. But for us, it wasn't the right thing because we need to do a lot of also static pages with search engine optimized, so we cannot just go full on with this kind of fancy magic.
Are you doing any type of scaling, or there's no need yet?
No need yet.
Have you had to upgrade Play?
Yes,
How
and
is that?
I have to say it wasn't an issue at all.
From
But-
which
But we upgraded from like 2.0 to 2.1. I think Manuel can tell you a little bit of a difference.
And if you upgraded the underlying library, it's got all kinds of errors because it wouldn't detect it.
that it will catch if your API changes and you didn't
Yeah.
adjust the code. The problem is more like regressions or code that was working in one, yeah, that's regressions, right? Code that did something and then changed the way it was doing things, and just plain bugs. For 4 months we couldn't use hot reloading because of a class loader bug. So your whole JVM was frozen. And
But that's
Fix it.
fault.
Huh?
Fix it. It's happens.
I spent enough time on it and I gave up. It was, and in the end, Guillaume Bott, the guy who coded the thing, fixed it. And I met him last year in November at the DevOps and had a beer and talked about this bug. And he told me, yeah, that was hard. And but they fixed most of these crucial things, and now it feels a lot better. So there is still this thing like the less compilation.
Yep.
That shows there is still a maturity problem in some of these things. And I think still the Scala templates, but that's an issue for Scala itself a
Yeah.
bit more, is that the compiler is still slow, and so the underlying principles of having everything statically compiled, even down to the URLs, that's brilliant, because yeah, you don't have to chase what URL is going to be broken if you use it correctly. You just have to still look at it a bit skeptically and not just think everything will work magically out of the box.
Yeah.
Because it doesn't.
Compilation speed is an issue still, especially if you make backend changes. But in my experience, the most critical stuff when you make a template change is actually quite fast now. So if you make just some HTML changes, you can have it in your browser in like a few seconds, even if you have 50 plus templates. But if you make a backend change, don't expect everything to refresh in 5 seconds. You have to wait a little bit longer.
Another question to your deployment process.
Yeah.
Do you manage to avoid downtime in this way? Or
We have at the moment we have downtime between stopping and restarting the Play server, which is like 3 seconds probably.
Okay.
And during that time, the reverse proxy shows some error page.
You made a nice error page? Or
Yes, very beautiful.
you still have to do that.
Wait.
What do you use for database migrations? Do you use
Ah, that's a good topic.
That's a good topic.
It's integrated into Play.
so you use the
Nice page, eh?
the built-in-
Yeah, exactly. That's the one.
monsters?
That's the,
This is the one.
This is cute.
So Play supports database evolutions. You write a script that's numbered, and you write your SQL up statements and down statements. So the things that you want to change from version 1 to version 2, add some columns or remove some columns, change some data, and then you write the reverse, what needs to be done to revert this change. And then you build it up, and it automatically, when it starts up, it checks the database version, and it automatically migrates the database.
I've seen that. I don't know how this works. I started using Play, and it shows in the UI, well, in the web page. You need to apply migration. Can
Yes.
you click?
Yes.
Can you automate this? When
Yes, it's just a configuration parameter. You can just say, yes, automatically do that. On the production server, it's done automatically. On the test server, we even run the down migrations automatically. So if we make some database changes, and then we need to revert them because we don't need them anymore for some reason, or we want to run a different branch of our system on the test server now, we can just switch and it will automatically downgrade the database and upgrade it to the different branch.
I have another question. How
Yep.
difficult is it to change? For example, you change how less files are compiled and things like this. These pipelines, it's compiling pipelines for resources.
Well, the pipeline is just a simple build tool, basically. It's just SBT. You can just, it's very simple. You override the default Play less compiler, and we didn't add anything else because now we do the less compilation. TeamCity does that basically in the compiling step. And for development, we don't compile it at all. We just run it in the browser.
So when it's in dev mode, you include this one JavaScript?
Exactly. In dev mode, we include less.js, and it compiles in the browser.
And when you are in production, Node.js compile that to
Exactly.
assets?
Exactly. Yep.
How
Okay.
is it for, I don't know if you do both Scala and AngularJS. Are you the guy that does Scala? And
Yes. Well, we have just two developers now. Stefan is sitting right behind you,
Okay.
and we are both doing front end and back end.
Backend. And how is it for you? Well, this is very interesting contrast. Now Scala is statically typed and AngularJS dynamically, very dynamic.
You mean the contrast between JavaScript and Scala?
Yes, and especially AngularJS, which is very automatically wow.
Wow.
Things happen,
Wow.
you don't know why, and it's like it's cool, but also me the feeling like I
Okay.
don't have a control. I don't know why this is happening.
Well, of course, there is a context switch when getting from JavaScript development to Scala, but there is a different concern. On the server side, you just want to provide your AngularJS with the right data. And AngularJS takes care of rendering the views and all that magic stuff when editing your formula or these kind of things. I think AngularJS would be also a completely different topic because we had to dig into some of the internals, not the internals, but we had to dig into at least a little bit more into AngularJS. We have some directives that we created, some elements that we use. So, but they work very nicely.